Hello, my name is Tara Sinclair, and I'm here today to present Forecasting Unemployment Insurance Claims in the Time of COVID-19. This is joint work with Will Larson of the Federal Housing Finance Agency, and I need to, at the beginning, state the disclaimer that this is a Federal Housing Finance Agency working paper, and these are preliminary products, and therefore all of the conclusions are the authors alone, and they should not be represented or interpreted as conveying an official FHFA analysis, opinion, or endorsement, and any errors or omissions are our responsibility. I am Tara Sinclair at the George Washington University, and I am very pleased to share this working paper with you all today. So let's begin. Oops. So we think about unemployment insurance claims. Many of us are well aware that these initial claims here in the US were recently at all-time highs. In fact, they were 6 times the highest prior peak and 30 times usual levels back in March and April. And so if we think about what this means from a forecasting or nowcasting perspective, this really adds some complexity to a standard time series forecasting model. And so in fact, forecasting this series is challenging due to the unconventional, and what I mean by unconventional is in a time series sense, properties of the series. If we think about it, having never seen these heights of 6 million plus claims before and starting out at a level of 251,000, these sorts of jumps are really difficult to model with a standard autoregressive model or something like that. And so we wanted to investigate this further and see if we could use some alternative techniques to model this series. So our primary research question is, how can we best forecast total US unemployment insurance claims? And so the first question is, why are we trying to forecast these unemployment insurance claims? Well, first of all, they're important in their own right. This is something that the states and the country needed to think about in terms of identifying how much these claims would be financially in terms of planning. But also during the initial states of the COVID-19 outbreak, these claims emerged as an economic indicator, and they were really giving timely and relevant information about the status of the US economy and the performance of the different states' labor markets. And furthermore, we believe our methods are generalizable, and so they could be applied to any variable in times of crisis. And so we thought this was a good place to start our analysis. So in terms of the literature that we're building on, if we think about during normal times, those simple time series models forecast best without really using disaggregate information. It's that large T that really gives us the information that we need in order to be successful at forecasting a time series. But during times of rapid change, that disaggregate information may be useful according to a long literature. And then, of course, there are other papers that are studying unemployment insurance claims and their forecasts during COVID-19, notably the Aronson et al. Paper that uses Google Trends and past hurricanes as a basis of a model, and the Goldsmith, Pinkham, and Sojourner state Google Trends paper that we're going to refer to in our analysis as well. So for our research, we're asking, first of all, are pre-period models exploiting large T useful? And as a corollary, is the post-COVID-19 a small T world, or is there something about the past history that could be informative, or when might that past history become informative again in the crisis? And then also, can we use disaggregate information? And in particular for us, what we mean by disaggregated information is information from state level data. In other words, to increase our N, will that help us improve forecasts in a small T world? And one area that we've seen other people work with is using Google Trends at the state level. And we're also going to add a new state level variable where we're looking at the emergency declarations, and we're using the timing of that, similar in spirit to research using studies on Walmart and their impact on regional economics. So just to preview the findings, first of all, when we ask our time series models usable, we say yes, and sooner than one might think. In our case, already 5 weeks after the crisis, we find that our historical time series models actually perform remarkably well, which we think is notable given commentary by people such as Justin Wolfers, who suggested that it might be hard to do time series macroeconometrics for a long while. We find that actually very quickly those models kick back in and perform well. And that's consistent with some other recent literature as well. When we ask, can we use disaggregate information from states, this large N, to improve forecasts in a small t world? We again find that yes, it's especially true during the first several weeks. And so we've got this mixed result where we do think that the time series models are still performing well within a short time period, but right around the crisis and that key critical time when we really need improvements in our forecasting model, this disaggregate information from states is critical. But that information could come from Google Trends, although that's not actually our best performing model. Instead, we find that these COVID-19 emergency declarations by state and exploiting the timing and the arrival of those declarations really improves our forecasting model. In fact, the first declared states are really accurate leading indicators of later UI patterns, at least or right around the initial part of the crisis. So in terms of data, we're using three main series: our advanced estimate of weekly initial unemployment insurance claims, Google Trends, and our emergency declarations data. And so those emergency declarations, basically what this does is this breaks our states up into 4 different categories. So we've got the states that are week 1 declarations, 2, 3, and 4. And so one way to think about our model is to think about it as being a panel that's been restructured around the date of declaration rather than around the actual timing. The way that we estimate our model is a standard time series, and therefore we use a bunch of declaration dummies in order to capture that same reorganization of the dates. But the time series structure makes sense just from a forecasting perspective, but the results are exactly the same as if we had a panel with 4 time periods, the week 1, 2, 3, and 4. So we use several different information sets and data structures. We've got this emergency declarations using normalized claims as our panel, and that's going to be our benchmark set of results. Then we've also got Google Trends at the state level to model normalized claims. Time series models, both univariate autoregressive models by state, and those are going to be modeling log claims. Time series models, the Google Trends national and normalized claims, and then the univariate AR models at the national level, also for the log claims. And the exact reasons why we're choosing normalized claims versus log claims in these different models can be explained more in the paper. We look at 10 forecast periods, where we start with the week ending March 14th, and we go through the week ending May 16th. And we basically find 4 different kinds of periods, even within this relatively short forecast period. So in periods 1 and 2, all the models are about the same, and that's not great. In periods 3 and 4, however, our declaration dummy variables model, which exploits this time dimension of the variation of the declaration of emergency by state, that panel model performs the best, notably so. Then in periods 5 and 6, the AR model catches back up, and so these time series models are already starting to look like our best model that we have. And then from period 7 on, the autoregressive models are the best. So note that overall, the declaration dummy variable models performs best throughout this whole sample, but that's probably not the right way to think about it. We like to think about it as these different time periods throughout this crisis sample, because each week really had its own features. And really when we think about these results, why does the state level information help in right around the key moments of the crisis, but then fade away pretty quickly and we're dominated again by the time series models? We really think that this is a trade-off between bias and variance. And you can see that here in these graphs, where we can see that our declaration dummy variables model doesn't show a bias, but it does show pretty wide variance. The state autoregressive model has lower variance, but early on, because of that big dramatic shock, it has a bias initially. And so that really leads to those models performing less well earlier on in the sample. And so here's another way to visualize that. We can see that, the blue line is the declarations, dummy variables, our state panel model. We can really see that its absolute error is substantially lower than the state time series models, right here in this key part of the shortly after the big shock, but when things are still really terribly bad in terms of unemployment claims. We can see that our model performs quite well, but then eventually they line back up again, and really it's notably quick. So what have we learned? If we ask, are time series models estimated using old data usable in the COVID-19 era? We will say yes, and it does not take many periods for those time series models to catch up. And that's consistent with the findings of several other recent papers that have been evaluating time series models performance in these crisis times. But we can also see another result, that we can use disaggregated information from states, or that large N, to improve forecasts in that small t world. But we're looking at a very, very small t world, because it's really just those first few weeks of the crisis. So just shortly after the shock has occurred, where that information is useful. And then afterwards, we want to go back to a time series model. And then in terms of thinking about our results being generalizable to other variables and other time periods, we think that this bias variance trade-off is a very classic result, and this is just a really nice illustration of it. And the timing differences in the disaggregate shocks, that may be particularly useful as leading indicators of many other disaggregates in the time of crisis. And so we think that this is an insight in this toolkit that we should have as we look to the potential of other crises in future time periods. And then if we think about the specific results in terms of like X weeks before we use the AR model, like should it always be 5 weeks or something like that? We think that that's really not likely generalizable. But this idea of maybe keeping both of these models in our toolkit, recognizing we shouldn't be throwing out the time series models, but also that these large N models might be helpful in narrow times around the crisis, that's really what we see as our key set of insights. So thank you very much. Obviously, I glossed over a lot of things in this quick presentation, but the paper is available from the FHFA working paper series. And please, you can also follow us both on Twitter, and our Twitter information is there on the screen. Thank you very much. Bye-bye.